This is the coolest upgrade I've made to my laser cutter, and while the smoke patterns look pretty cool now, it's what changes when we close the lid that has me excited. All these shenanigans started when I wanted to gain back a few inches here, because this just feels like a waste of space. I wanted something that was easy to swap in and out, maintained the same performance as the existing tube, and something that protruded less than 2 inches from the back of the machine. There's a couple listings on Etsy for these low-profile port extensions, but they're built for a 3-inch tube. My exhaust port is 6 inches, so to maintain the airflow, I think we're going to need something a bit wider. For this experiment, let's oversimplify the problem, ignore fluid dynamics, and just assume that cross-sectional area is the only factor we care about. For a 6-inch circle, that area is about 28 square inches. To flatten the duct down to 1.5 inches deep while maintaining that cross-sectional area, our duct needs to be around 19 inches wide. And while we model that up, there's another bottleneck that we come up against. How do you transition from a circle to a stretched out rectangle? Clearly, one thing we can't do is directly connect the profiles, because then this cross-section is way too small. As far as I can tell, the limiting cross-section then becomes this cylindrical surface or plane. And if we unwrap that, we find the surface area is just the circumference times the depth. So 6 times pi times 1.5 inches, which is right around 28 square inches. But that's not a coincidence. This is actually how I chose the depth of 1.5 inches in the first place. I knew all these variables, and then I solved for the depth. To try to make sure that all this cross-section is actually used, I added extra volume all around the circular inlet port. It's kind of fun building these one-off ideas because I don't have to go through the thought process of making it efficient to assemble. All these pieces are held together with tape and superglue, and then the cracks are filled in with this 3D pen, which is basically a filament hot glue gun. It's just plain bad product design, but luckily this isn't a product, so it doesn't matter. So the width between these two lines here is exactly 479 millimeters. Then we measure this piece of plastic I got, and would you look at that? 480 millimeters. I literally have 0.6 millimeters of extra material. Here goes. Here's the alignment marker. The other one. FYI, I'm on day 25 of posting 100 days of creative projects, so if you found this one interesting, you might consider subscribing to follow along with that. There we go. That's the first part I've ever cut that's bigger than my cutting area. This is the piece I cut out, and appears to be like that couple millimeters too long. I'm not quite sure where that discrepancy came from, but I'm thinking if I put it back in the laser, because I still have those registration points on both sides. If I just register to a point that's a couple millimeters ahead of it, I should be able to kind of run this cut again and kind of shift this upwards. It's honestly a little bit bothersome that this isn't black like the rest of it, so. Okay, so I have my plastic sheet for here, but I need to cover this slot with something clear so that the air can't pass through. Found this piece of plastic that's like perfect size that I could cut out a piece. But that felt a little overkill, so I just went with packaging tape. Now to try to answer the big question, does adding all this extra duct space actually help the performance? Like, will some of the air actually come up through this space here and then somehow circle its way down to the outlet? To visualize the answer, I pointed my laser level through the window in the bottom and juiced up my little fog machine. I was initially a little disappointed to see that most of the smoke trail is going directly from the inlet to the outlet port, without using much of the rest of the duct enclosure. But if we slow things down here, I bet you can see the mistake I made. Because I had the fog machine pointed directly at the exhaust port, and because the lid was open, the fog was only actually representing a small portion of the total airflow. If I point the fog machine this way, and then close the lid, the fog better disperses into the enclosure, which allows us to see this. I think it's really cool to see the transitioning between turbulent and almost laminar-like flow. It kind of reminds me of watching a campfire. Honestly, I could watch this for hours if I wasn't the one paying for the fog juice. Oh, and for the more analytical viewers, I ran some very unscientific wind speed tests, which measured a pretty significant drop-off in performance while using my flattened duct. But then I noticed that my control had the flexible tube fully pulled in extension, which tightens the fold in the duct material and maximizes the inner diameter. So I tried extending the tube while testing my flat duct, and that gave results that were much closer to the control numbers, which is honestly good enough for me.